So Wakissha Math Paper 1, 2026, Senior 6, Item 4. This is under Part 2. The first item, Item 1 is compulsory. Part 1, Section B has Item 2, Item 3. Then Part 2 has Item 4, Item 5. In each part, you choose just a number. This looks at basically calculus, integration, differentiation. The is a local cooperative is establishing a prairie project and intends to use 100 meters of protective netting to enclose a rectangular area for the beehives. The project requires a minimum of 500 meters squared for, so this is minimum area. Minimum area should be 500. So the area should be, this should be the least 500 meters squared for the hives and pollinator gardens to be effective. Additionally, before we proceed, when you go to the task according to the given information, help the cooperative establish whether the available netting is sufficient to enclose the required area of the apiary. So they have given us the project intends to use 100 meters of protective netting. So the perimeter of the protective netting is just P is equal to 100 meters. But now we are going to get the dimensions, which will give us the minimum of 500 meters. So we know that since it is going to be rectangular piece of land, so perimeter is given by 2 into length plus width. Our perimeter is 100 is equal to 2 into length plus width. Make any of this to the subject, divide by 250 is equal to L plus W, implying that W is 50 minus L. Now I go to the area and I say area is given by length times width, but in this case our area is given by length, which is L, width is 50 minus L, but now the area that we are dealing with should be, say, 500, which will be 50 L minus L squared. Now there is a condition that they talked about, and that condition was, the project requires a minimum area, minimum. So if they're requiring a minimum area, then it should also have come from a minimum length, and so on and so forth. So we are going to go ahead and differentiate our area before we do the substitution. We are going to differentiate our area, which is having got this for minimum area, we shall say the L is equal to, so minimum area should come from 50 minus 2L. Then we are saying that for minimum area, for area minimum, the derivative of the area with respect to the length should be equal to 0. So 0 will be equal to 50 minus 2L. Bring the 2 all this side will give us L as 25. These are meters. Then when L is 25, get W. W will be 50 minus 25. W will also be 25 meters. Now, these are the dimensions that will give me the minimum area. But they said there is a condition. They told us that the project requires a minimum area of 500 meters squared. So it means that what it is interested in is having an area which is this and above. So now area for the dimensions we have will be 25, which is the length, times the width, which is also 25. When you square 25, we shall get 6 6.25 meters squared. This is the minimum area. They want us to help the cooperative establish whether the available netting is sufficient to enclose the required area. And I'm saying yes, because they want to fence just 500 meters, but according to the dimensions, which will give a minimum area, they are giving us 625. So meaning that this will be sufficient. Part B. Part B, I'm going to get it from the information that I have. I proceed. They went ahead and said that additionally, the cooperative has designed a central honey processing facility with a cylindrical storage vat. The vat is to be constructed such that the sum of its height and the base radius is 15. Height, base radius is 15. This is a cylinder. The facility requires a storage capacity of at least 400 meters cubed of the harvest to be considered viable. It requires at least, so that is greater or equal to 400 meters cubed to be viable. Then part B, the proposed storage vat design can provide, want to help establish whether the proposed storage vat design can provide enough capacity to sustain the processing facility. So still we are going to consider our cylinder. They have given us H plus R is equal to 15, but the facility requires a storage capacity of at least 400. So we are going to say volume of a cylinder is given by pi r squared h. But now in this case, I have radius and h, meaning that it is very hard for me to get the derivative of volume with respect to these two changing variables. That's why this condition was given. So I can substitute for h such that h is equal to 15 minus r. Why are you not substituting for r? I don't want to complicate my life with squaring. So v is going to be equal to pi times the radius, which is r squared, then times height, that is 15 minus r. On opening brackets, I'll come up with 15 pi r squared, then minus pi r cubed. That is my volume that I've come up with. But there is something that we need to look at. The vat is to be considered to be constructed with the sum of that. Then the facility requires a storage capacity of at least this to be. So this is now our minimum. Still, we are going to use the same approach up there. We need to get the derivative of the volume with respect to the radius in this case. The two drops is multiplied with 15, that is a 30 pi, reduce the power by 1, r minus 3 drops, that is 3 pi, reduce the power by 1, we have differentiated. Then we are saying, because we are saying at least, so we are saying for volume minimum, the derivative of the volume with respect to the parameter we are differentiating it with should be equal to 0. 0 will equal to 30 pi r minus 3 pi r squared. We are going to factor out the common terms. 0 is equal to, I have the 3 pi and r. These ones are common. I stay with the 10. I stay with the 10. Then pi has gone. R is out. Minus 3 out, pi out, 1 r out. This. So either 3 pi r is equal to 0, implying that r is equal to 0. I'm saying either 3 pi r is equal to 0, r is equal to 0, or 10 minus r is equal to 0. This bracket is also equal to 0. implying that R is equal to 10. These are meters. Now, since we cannot have zero radius and it is going to contain this one I just discard, and now I deal with the R, which is 10. The question is, the proposed storage provide enough capacity, so I need to get the capacity. R is 10. If R is 10, then meters, what is H going to be? H is going to be 15 minus 10, which is 5 meters. Then go back in the formula of calculating the volume, and we say volume is equal to pi, then times radius, which is 10 squared, then times 5. So the volume, the capacity is going to be, that is 500 pi meters cubed, which is 1570.7963 meters cubed. They say that it should be greater than 400 to be greater than 400 to be considered viable, at least. So yes, it is viable because it is greater than the 400 meters cubed. The conclusion is like that. Then when you proceed, they went ahead and said that to monitor hive health, the cooperative recorded an initial bee colony population. P, the initial one, which is when T is equal to 0, it was 2,000. The population changes over time due to seasonal growth and natural attrition modeled by dP dt, which is going to be equal to 0.05p minus 150. If this is the initial population, I can even start by testing. I'm having 2,000. I have 2,000 times 0.05 minus 150. If I'm to consider this as my initial, and I have dP dt, it is going to be equal to a negative 50. So this one shows that my population, surely it is not going to be increasing, it is going to be reducing, if this is the initial. Okay, now let us go ahead and deal with this. Take the 0.5p this side. We have dP dt, then minus 0.05p is equal to negative 150, first order homogeneous. So we are supposed to get the integrating factor. Our integrating factor is equal to exponential the integral of the coefficient of p, which is a negative 0.05 with respect to t. Then our integrating factor that we are going to multiply on each term to make it exact will be, integrating this is going to give us exponential negative 0.05t. Don't put the constant of integration here. Then get this integrating factor, multiply it here, here, and here, such that we make it exact. So this is going to be exponential negative 0.05t times dp dt, then minus, still the same thing here. I can start with the negative 0.05p here, then exponential negative 0.05t, which is our integrating factor we are putting on each term. Also, this side, negative 150 times my integrating factor that I've established, which is exponential negative 0.05t. Then d dt of my integrating factor, which is exponential negative 0.05t, times the coefficient, the p, times this p here, this one here, which is times p. Now, as if you differentiate this, it will give you this. Because this is the product rule, we say keep this constant, differentiate p with respect to t, that is the p dt. Then keep p constant, differentiate this, the negative drops, then we have it like that, is equal to, this is a negative 150 exponential negative 0.05 t. Then separate, since it is exact, I separate variables and I integrate. This is a d exponential negative 0.05 t p is equal to, the dt has crossed, negative 150 exponential negative 0.05 t. Now it is dt. After separating variables, I can introduce the integral sign such that this crosses out with that. And I have, let me start with the p. P exponential negative 0.05 t being equal to, when I integrate this, this is a constant negative 150. When I integrate an exponential, I differentiate this. When I differentiate this, I get a negative 0.05. So the value that I get here, after differentiating the whole of this with the t goes to a 1. It is this that I divide. In other words, if you have y is equal to exponential 2x, if I differentiate 2x, I get 2. So meaning that the integral of exponential 2x dx is simply going to be a half exponential 2x. You divide by what you get. So I'm going to divide by a negative 0.05, then exponential. This stays as it is, like we are seeing. The 2x stays up here in the final answer. Negative 0.05 t. But now, this must give me a constant of integration. If I simplify this, 150 divided by 0.05, this is just 3,000. So I can rewrite it as p exponential negative 0.05 t is equal to, this is going to become a positive 3,000 exponential negative 0.05 t plus the constant of integration. That is, I've solved that e. Then they went ahead and said that they gave us p naught when t is equal to 0. So I'm going to just use this exact space and we see if p is equal to 0, because I want to get this constant of integration. When p is 2000, t is equal to 0. So I'm going to put here 0, and then number multiplied by 0, it will give me 0. Exponential of 0 is a 1. P, we are saying p is 2000. This, I'm saying 2000. Exponential 0 is 1 is equal to 3000 exponential. This is going to also be t times 0, which, sorry, this times 0, which is a 0. Exponential 0 is 1 plus c. This implies that c is a negative 1000. Still, I get it and substitute it back here. Now, the equation that I'm going to be dealing with to get the other answers is going to be p exponential negative 0.05 t being equal to 3000 exponential negative 0.05 t. Now, where there is c, I'm putting there minus 1000. Now, the next question, they either give you p and ask for t, or they give you t and ask for p. Let us see what they have given us. For the project to be deemed sustainable, the colony population must reach at least 4,000 within 10 years. Within 10 years. So let me substitute t is equal to 10 years. I see if p is going to be 4,000. But like I said, this must be reducing according to the E that was given to us. Now this is going to be P exponential negative 0.5. If I'm multiplying by 10, 1 0 just goes off, being equal to 3,000 exponential negative 0.5 minus 1,000. So let me start with the right hand side. I have 3,000, 3 exponent 3, then to the power negative 0.5. This is, 3 exponent 3 exponential negative 0.5 minus 1,000. Then I divide it by exponential negative 0.5. So my P will just approximate to 1,351.2. These are hives. Not hives, they are bees. Because you're looking at bees. So, like I said, we started with 2,000. After 10 years, they are 1,000. So it will not be, the colony population will not be sustainable within 10 years. And I think that's all. Thanks for watching. We meet in item 5.